Welcome everyone, and thank you for attending this brief presentation on my master's thesis project titled Regionalized Life Cycle Assessment of Renewable Energy and Waste Valorization Options for the Canadian Egg Supply Chains. So to briefly cover the Canadian egg industry as a whole, egg production volumes in Canada have increased now by 15% in the past 6 years alone. And manure management has been found through previous life cycle assessment studies as a significant contributor to overall emissions in layer facilities, and this varies between province to province. There are other waste streams from the egg industry that also need to be addressed and valorized, such as spent hens and feather waste, as well as eggshells. Direct energy use also can be improved using renewable energy technologies, as this varies between 9 to 12% depending on province as well. So life cycle thinking is a critical ideology that avoids problem shifting and is key to attaining a circular economy, which I'm sure if you have been in this field of sustainability, you have heard this term very often now. It's a very popularized term. And life cycle assessment itself is a life cycle thinking based tool, and it has been designed for the purposes of pinpointing the environmental burdens associated with the product's life cycle. Now, to take it a step further, there is now a more detailed type of life cycle assessment that we in the LCA community are trying to strive towards, which is a regionalized life cycle assessment. And so site generic is typically known as a global LCA. Site dependent is regional and national, and site specific then gets into the very specific local locations. And the purpose of a regionalized life cycle assessment is to increase the accuracy and representativeness of your LCA results. And GIS, Geographic Information Systems, is a great tool for acquiring spatial data for regionalized life cycle assessment, and also as a site selection tool. The two primary research questions for this master's project, hence, are to develop methods to perform regionalized life cycle assessment studies and perform them for the purposes of a comparison of potential green technology options for egg farms in Canada, to potentially understand what the net emissions benefits would be to introduce a different type of direct energy use to farms, and secondly, to produce site suitability maps of these site-specific green technology deployment considerations, such as climate factors and solar and wind energy potentials, using data that's collected as part of the life cycle inventory phase, as well as using GIS. So the methods used for the regionalized life cycle assessment study included the 4 phases of an LCA, which include goal and scope, inventory analysis, impact assessment, and a final interpretation phase. And an attributional life cycle assessment modeling approach was used. This is known as an accounting approach and a retrospective approach as well. The main stakeholders of the study were considered as egg farmers of Canada, the main funders of this project, green technology industry, and policymakers. And finally, cradle to farm gate system boundaries was used with a function unit of 1 ton of eggs, and where needed 1 kilowatt hours of electricity produced. Both foreground and background system data were used as well. For the impact assessment phase, several different impact categories were chosen based on the literature at hand. The World Impact Plus methods was used, as this is more catered towards a regionalized life cycle assessment, and OpenLCA is software that was used to do the modeling and assessment. Environmental payback time played a role as well in this research project to narrow down specific technologies that suited better in particular locations. And finally, data quality and uncertainty, as well as sensitivity analysis, were carried out as well. So this is just a quick overview of how GIS can be used in combination with LCA. And so here we have the wind power potential in Canada and location of specific egg farms. And this was used to then narrow down how many specific farms are located in each wind power potential location based on meters per second, and then this helped to then figure out what the specific environmental impact payback times were in order to then use these infrastructures in place of direct energy use from the grid to figure out what the difference in impacts would be. And finally, similarly, we have the same sort of solar PV potential for kilowatt hours and specific locations of egg farms. And similarly, the same approach was taken as I did for the wind. And with that comes the end of my presentation. Thank you all for your attention. I'm currently in the impact assessment phase, trying to output some results. So I'm sorry I don't have any to share with you today, but please keep your eyes peeled for any papers in the future that I publish for to present those results. And I can now take questions. Thank you.
Oh, I forgot to unmute myself. Thank you very much for another nice presentation. I do have a questions that maybe you can clarify here. In your assessment, when you utilize the potential for wind powered or the potential for solar powered. So now when it comes to the implementation, are you anticipating that individual producers or farmers may then go towards installing solar power on their farm, or are you relying more on the power authority to use that information to develop those power investments?
Yes, thanks for your question. I believe it would be the farmers directly, because this whatever outputs come out of this research are going into the NEST tool that was just presented previously. Sorry, sorry about that. So basically it would be, we're looking to farmers themselves to install these technologies and take the investment. But of course, this is industry-led research, so the industry will also support whatever results are produced.
I think there may also be a values in having the power authorities in the different areas to also have access to the data to plan and develop their own future plan for the grid. Yeah. I have a question here from Matt Orichak. What about geothermal?
Yeah, during my literature review, I have a whole section in my thesis which discusses all the different energies available countrywide, and it came down to these two particular ones because they are the best suited for on-farm installation, and that's what we're looking at specifically for this research. Geothermal is definitely an option, but it would be more of a grid supported energy and not necessarily one that a farmer can install themselves and then benefit from the surplus energy.
All right, thank you very much. Great presentation.